All right, so page 79, right? Says they randomly sample 50 people from the population at large. Would this method ensure sampling distribution is normal? Okay, so they know that 83%, you know, they've gotten this, they've heard this, they've figured this out, drink coffee. So what we're going to do is we're going to go 50 times 0.83. And if that's greater than or equal 10, then we're also going to go 50 times 1 minus 0.83. And if those come out to be greater than 10, that's great. So let's see, 50 times 0.83 on a calculator says 41.5. Hey, give me some love. Good to see you. So 41, it's over 41, so is 41 bigger than 10? This week it is. So satisfy that first one.
So would one be yes or fine?
So the first one's yeah. Well, hang on, we got to find the second one though. So that came out to 41.5. So this one checks off, but it also has to pass this one. So this becomes 50. 1 minus 0.83 is 0.17. So then if you go 50 times 0.17, that comes out to 8.5. And is 8.5 greater than 10?
No.
Nope. So this, in theory, would not make a good normal distribution from our sampling, being we knew that the 83%. The 83% doesn't mean we know the total population. It was just they'd somehow figured out a survey that found out 83% worked. Okay, but that's not going to stop us from finding the mean. So the mean is the 83%. Or you could write 0.83. It's kind of up to you. And then we want to find the standard error. Remember, the standard error takes place of the standard deviation. So that's going to be P times 1 minus P, all divided by 50. So in this case, this is our P value, or this is P, so 0.83. And then 1 minus 0.83 divided by 50, and this is going to find our standard error. So we do this correctly on a calculator. It should come out to 0.053, which if I'm using the 83% or the 0.83, then our standard error is 0.053. If we are using the 83%, then we would make this a percent. So what's the right way to do it? Keep the percents with the percents, keep the decimals with the decimals, don't mix a percent with a decimal. Let's see. We're on page 75, we just started. All right, so that's our standard error. So I'm just going to keep the, I'm going to keep it as decimals. So if I could take that, if I wanted to draw a normal distribution, and I knew that the mean is 0.83, and the standard error is 0.053, we draw our normal distribution, even though we know it's not a normal distribution because it didn't satisfy the characteristics up above. We have 0.83 in the middle, and then this comes out to, let's just keep this simple. Let's make that 0.05. So that'll be 0.88, 0.93, and 0.98. And then if I subtract 0.05 from it, I get 0.78, 0.73, and 0.68. Okay. And if we go into and use the 68, 95, 99, 7 rule, what captures the middle 95 of random sample 50? So out to here is 68%. So I go out one more, and that captures the 95%. So from 0.73 to 0.93, that would capture that. Okay. All right, we good so far? Kind of moving, but hopefully you're staying on board. Number 5 says, if the sample size is increased from 50 to 100, what happens to the mean and the standard deviation? So the mean will stay the same. The mean is going to be the same. And then because we had used this changes to 100. So this means that our standard error gets smaller. So what we do is we start approaching the parameter that we think that it's at, but we don't know for sure what it's at. Okay. All right. We good so far? Any questions there? Number 6, assume that a random sample, gotta move that up. Everyone's good? All right, 6 and 7. Assume a random sample is chosen. Oh wait, assume a random sample is chosen from only immediate area around the new chain stores. Name an advantage and a disadvantage of conducting this random survey in this way. So for number 6, an advantage, this is easier to do because it's local. Okay, we're only worried about what's around our store. We're not worried about what's going on in Tennessee. Okay, if we're not opening a coffee store there. Disadvantage might be, so this won't be representative of all future customers. Okay, so let's say you're doing a survey in a new area of town where they're doing a lot of building. You do this survey when you have like only 10% of the homes that are built in that area. This might not show the same type of thing once all the homes are built. Okay. And let's see. What is the minimum sample size needed to pass your assumptions? Okay, so you remember it's n times p, this is number 7, is greater than or equal to 10. And then it's n times 1 minus p, which is also greater than or equal to 10. So we're trying to figure out n in both of these characteristics. Okay, so we want to see if this is going to work. So if I go n times p, well, I knew that p is equal to 0.83. And I did this math, and I just said, oh, okay, divide each side by 0.83, just using some basic algebra. So n has got to be greater than or equal to 10 divided by 0.83. So we needed a sample size bigger than 12.05, but that's not going to hold true for both. So we'll do the same thing over here. If I go n, and then if I did the 1 minus p, we found out that this was 0.17. It's greater than or equal to 10. So if I go divide each side by 0.17, so this is going to show us that our sample should be greater than 58.82. So I would say 59 is our minimum to make that work. Okay. So why not 58.82? Well, just because, Leroy, who's missing a thumb and a half a foot, he doesn't count as less than a person, so you're not going to get a fractional amount of people. All right. Questions for me? Are we okay? Everybody happy? Hey, you guys surviving without the TikTok? Oh, it's back. Oh, good. Oh, I wasn't able to sleep last night. All right. Woo. This might be old data. I'm sure it is. I don't know if it's accurate or not. It says currently Currently, 13% of the population of the United States is a senior citizen.
How many?
They say 13%. I think they're off a little bit, but hey, we'll go with it.
Yeah, we should make it lower.
Says create a sampling distribution of random sample size 36. Okay. So we're doing, this is number 8. We're talking about 36 people. They're claiming 13% are senior citizens. So 13% is the same thing as 0.13. So I want to find my standard error. So I'm going to go the square root of 0.13 and then 1 minus 0.13 divided by 36. So do the little bit of math here. That should come out to roughly 0.06, ballparking it. Okay, round into 2 decimal places. I think I had to round up a little bit because it's 0.056. All right, that's my standard error. So if we were to draw our sample distribution based on this, let's pretend I can draw real well. So that means that 0.13 here is, or 13%. So that's 0.19, that's 0.25, that's 0.31. Go the other way, that's 0.07, 0.01, negative 0.05. Oh, we got a negative. How do we have a negative percent? I guess we don't, but okay. So bless you. So what will capture that 68%? So this is 68% of our population here. So the answer to number 9, we're going to go from 0.07 to 0.19 as far as percents go. So hopefully we capture our parameter within there. And let's see. Number 10, how likely is it that you would survey 36 random people and end up with either 11% or more who are senior citizens? Guess what time it is? It's our favorite people, the Desmos family. I don't know if it's really a family or not. All right, Desmos. Let's see what we got. Stirrups page. Desmos. Graphing calculator. You guys should be getting pretty good at this Desmos. At least you know where to find it now. Normal distribution of 0.13. Standard error is 0.06. So there's our normal distribution in this case. And if we wanted to conduct a survey, yeah, this is number 10. So we want to see if we have higher than 11% of our population. Is that right? 0.11. All right. So you're talking about 63%. 63% of our population should be should show 11% or more are senior citizens. Okay. That's number 10. So you everyone have that? You got 0.63 or 63%. All right. Yeah. If you randomly selected, if you did another random sample of 36 people, that's the percent chance that you would have 11% or greater would fall into senior citizen category. All right. Then I'm on number 11. I'm trying to match this up. You conduct a survey and obtain a senior citizen percentage that is 2.5 standard deviations below the mean. What percent is that taking place? Ooh, 2.5% below the mean. Okay. 2.5 standard deviations below the mean. All right. So on number 12, So we are, or 11, thank you. So 2.5 standard deviations below the mean, which if you look back at our graph, 2.5 standard deviations, here's 1, here's 2. So you're talking about like this area down here. Standard deviations or less. Yeah, so yeah, it's going to be a pretty small thing. So we can actually do this on Desmos. So this is going to be that you put the period inverse CDF, and then let's see. No, I'm doing it wrong. I'm doing it wrong, guys. Just for fun, I'm doing it wrong. All right. So I got to go back to this. How am I going to do this? Oh, let's see.
How did you know? Come on.
There you go. Yeah, that's right. All right. So if you take, because this is a standard deviation, if you take the standard error is 0.06. If I multiply that with the 2.5, that's going to come out to 0.125. So I can take that 0.125 and plug it into Desmos as the lower bound. So I'm going to get rid of this. We want below this, so that's going to be negative infinity, 0.125. Wait, was that what my math was?
Isn't it 0.012?
I think you multiply 0.06 by 2.5, but then you subtract that from the.
I think what you do is you 0.6 times 2.5, and then you subtract 0.13 from that. 2.5 from that means, right?
I'm off a little bit.
So you find the standard deviation and magnify 2.5.
I think what we actually have to do is look at a z-score. So z-score equation, oh my gosh, I just totally blanked it. I'm going to skip this one for now. I mean, I'm coming up, I only have the answers on this, so I came up with negative 2%, but I don't remember. That's what you got?
Yeah.
What'd you do?
So I took my equation was 0.13 minus parentheses 0.06 multiplied by 2.5.
2.5?
Yeah.
Okay. I'll go with that. I know that this would not have shown up on, this is not on a quiz. I know that for sure. All right. Back corner, you okay? All right. 13. Or 12. 12. Does this fail any of our assumptions? I'm going to say probably. So if I go 36 times the 0.13, is that greater than 10? Or is 36 times 1 minus 0.13, is that greater than 10? So just do a little math. So 36 times 0.13 comes out to 4.68. That is smaller. So this is a big no. I wouldn't even have to go further. There's no reason to go and say, well, 36 times 0.87. Yeah, this one comes out to 31.32. So this one's a yes, but because we got this being no here, we are not falling into a normal distribution. And what is your...
You might have it.
right, 13. Assume that you conduct a sample of local shopping mall at 9 a.m. on a random Monday. Select random shoppers. Identify 2 problems here. Okay, so assume you conduct a sample of local shopping at 9 a.m. So local, that is bad. That's a B for bad. All right, 9 a.m. Bad. We don't have random taking place. This is not representative of our whole thing. If I walked over to that King Soopers over there at 9 a.m., started collecting data, I'm more than likely not going to get a nice set of random sample of people because I'm so in on that. And then it says, assume your random sample of 36 adults produces 10 seniors. Identify P and P hat. All right, so we want number 14. We want P and we want P hat. So P is 10 over 36. So 10 divided by 36 is Wait a minute. Wait.
6 adults bred together and they made 10 seniors.
Hang on. P. Oh. I flip-flopped my P and my P hat. So this is the 0.13 from above. And then I'm going to go 10 divided by 36, which comes out to 0.27. 0.277. That's our P hat. All right. Yeehaw. So one's the sample probability. One is the and one is our probability we're trying to aim towards. One's our sample probability. All right. So make sure your name is on that photo. If you're handing anything else in, let me know what you handed me. Number 1. Friends, if you happen to miss the quiz we did the other day, it's your responsibility to come pick it up with me on an off period. If you want half your points back, you need to make it up sometime by Friday, so you can come in and see me before school, or you can come in during advisory, or you can come in during 1st, 5th, and 6th. Any over here? Still working? And then I'll collect down. Collect down. All right. All right. So I don't really have time. Oh, I'm so sorry. I didn't really have time to teach this next lesson, but this is going to start getting into something called confidence intervals. And then the next section is how to figure out confidence intervals. Nice thing about this week, I don't have any tests or quizzes planned, okay? I will tell you Thursday next week, so not this coming Thursday, Thursday next week, I have a sub day, okay? So we'll probably throw a quiz in on that day. It always kind of makes it easy for you guys to do that, right?